Next, I'm going to talk about internal resistance. For an ideal source of EMF, for example batteries, the potential difference ataupun voltage across the source is equal to the EMF. So the potential difference or voltage of the battery should be the same as the EMF lah, or VAB is equivalent to EMF is also equivalent to I times R. However, real sources of EMF don't behave ideally. Charge moving through the material of any sources of EMF encounters resistance too. For example, let's use our previous picture as before. So now we have a very simple circuit with a battery and also a light bulb. So as I mentioned before, current will move from a higher potential towards a lower potential like this. And then at the end of it, this will come lower and this will come higher. So as I mentioned, it also moves in the battery. However, as it moves in the battery, this current will also encounter some resistance inside the battery. So this is what we call as internal resistance. Because in the battery is actually electrolyte battery, right? It has some chemicals inside it that can generate electricity. So due to all the chemical interaction between the electrolytes and so on, we have also the electrodes and so on, there will be some sort of electric internal resistance inside the battery. And internal resistance is denoted by a small r. So as the current moves through internal resistance R, it experiences a drop in potential equal to IR. So as we know, V equals to IR. So whenever this current moves from this lower potential area to this higher potential area, so it will also experience a drop of potential, and that drop of potential will be equivalent to I times small r. Thus, when the current flowing through a source from the negative terminal to the positive terminal, the potential difference between A and B will be VAB is equal to EMF minus IR. So, okay, so let's talk about this one. So this EMF is actually what the battery will provide. So for example, if you have a double A battery, for double A battery, the EMF will be 1.5 voltage because that is a typical voltage for a double A battery. You can actually buy a double A battery and then you can check on the label. It will mention there somewhere 1.5 volt. However, in real life, the battery itself will have some internal resistance inside it. So the battery actually cannot provide 1.5 volt. Instead, it will provide maybe 1. So EMF is 1.5 voltage, and then as I mentioned before, this battery is only able to provide maybe 1.48 voltage, maybe. So this is actually what the voltage difference will be across these 2 points, point A, across the terminal of the battery, and across point B. So where does the 0.02 go? Okay, this is actually equivalent to IR. So this is what is called as the potential drop that is equal to IR. This is the potential drop due to the internal resistance of the battery. So if I can use this picture up over here, between point H and point L, between the two ends of the battery is only able to generate 1.48 voltage. For example, if you take a voltmeter or multimeter and then you put it to your battery and you check what is the volt, you will only get 1.48, 1.45 maybe. You will never get 1.5. So what happened to the 0.02? 0.02 is actually what is lost when the current moves from this low area to this higher area. So this is where the 0.02 will be gone. So the terminal voltage VAB of the battery is reduced for closed circuit due to internal resistance inside the source. Okay, this voltage VAB equals to EMF minus IR. This voltage is called the terminal voltage because this is the final voltage that the battery can provide to the circuit. And this voltage is less than EMF due to internal resistance. For example, a 1.5 volt battery have 1.5 volt of EMF but lower amount of VAB. This is another example, a circuit where we have the battery with EMF of 12 volt and an internal resistance of 2 ohm. This battery is now connected to a resistance of 4 ohm, an ammeter and also a voltmeter. So if you calculate using the amount given here, you will get the current will be 2 ampere, and then the voltage will get 8 volt. So this VAB is actually what will come out from the battery. This is the point, the voltage, the potential difference between point A, which is outside of the battery, and point B, which is also outside of the battery. So this is what you can actually see using the voltmeter. However, if you look closely inside the battery, this battery is supposed to be able to give out EMF of 12 voltage. But due to the resistance, the 2 ohm internal resistance, that's why the voltage that comes out is only 8 volt. Okay, next, this resistance, 4 ohm of resistance that is outside of the battery, that is included in the circuit, is called the load resistance. You call this load is because the energy supplied by the battery is consumed by the resistor. And other than this equation, you also have two more equations, which is IR equals to EMF minus I small r. This is because V is equivalent to IR. And if you rearrange this equation, finally you will get I equal to EMF over R plus R, where R is the resistance of the load resistance and small r is the internal resistance. Okay, next I'm going to talk about symbols for the circuit diagram. So a straight line ataupun just a black line is typically a conductor with negligible resistance, which has a very low amount of resistance. And then this zigzag line is the resistor. These two straight lines, one longer than another, is the source of EMF, typically a battery. The longer line stands for the positive terminal. Typically in this class, I will write internal resistance of a battery as something like this. I will put the resistance just next to the battery and then I will enclose it with a box lah. So a circle with V and circle with A means voltmeter and also ammeter. So a voltmeter measures potential difference between its terminals. Ideal voltmeters have infinitely large resistance and measures potential difference without any current diverting through it. An ammeter, it measures the current passing through it. Ideal ammeters have zero resistance and no potential difference between its terminals. I will talk more about voltmeter and ammeter in our next chapter.